The difference is that the variable is the base, not the exponent. So we have to kind of think a little bit differently about how we might solve it. And this is more like an equation we would have solved before yesterday. If I said b to the 5 halves, how could you write that with a radical?
The fifth power squared as square to the fifth power.
Square root to the 5th power. Okay, and it doesn't matter if that 5th is under the radical or outside the radical. So from there, what do we do if I want to solve for b? Okay, we could start off by squaring both sides. That would cancel our square root. BFF equals 243 squared, 59,049. Then how do you get rid of the 5th power? Do we need a plus or minus?
Yes. On the right side, right?
We only do it if it's an even root. So if you're adding like a square root, 4th root, 6th root, we do plus or minus. Odd roots, we do not. So then if we do the 5th root of that, we get 9. All right, part B. So how would we write this one with the radical?
Radical 3 h to the fourth power.
Okay, so what do you want to do first?
Take the cube plus sides.
So 1 to the 3rd. How do we get rid of a 4th power?
Fourth root.
And since that is even, that one we need a plus or minus. So plus or minus, and the 4th root of that is 27. So if your variable is the base, you can kind of just solve it like normal. Yes, sir.
Could you also solve it by applying the right, so taking the exponent and applying the opposite reciprocal as an exponent to the right side?
You can. The only thing you have to watch is make sure you're watching if you have to do a plus or minus. So if you do that, basically if the denominator is even, you need to throw a plus and minus on it.
What if it's like a positive fraction? Would that even matter? Would we just do it as a whole number?
You just do it as a whole number then.
Well, what about like a 5 over 4 or something like that?
So you would do the 4/5 power to each side, and then since the denominator is,
A 4, like you do like on the right side you do like a 5 over 4.
so then you would have to put the plus or minus. So you could do whatever number to the 5/4 power, but then put the plus or minus on that. Other questions? So the last topic in this section is interest. And that's why I went ahead and printed this for you, just so we kind of didn't have to copy down the entire problem as we went through. So interest, we've talked about some simple interest at the beginning when we did principal times rate times time equals interest. But in the real world, most of the time it's not just simple interest. You know, if you take out a loan, they don't just calculate the interest one time and make you pay it. You have to pay compound interest, okay? And so there are different periods when they compound. So compound interest basically means they stop, calculate the interest, add that to the beginning amount, and then keep going. And so the amount is constantly growing. What would annually mean? Mm-hmm. One time per year. Semi-annually.
Once every other year.
It actually typically means twice a year when they talk about it in this sense. What would quarterly be? Monthly? And this is one that nobody ever knows. How many- You'd be amazed at how many people don't know that. And we are excluding leap years on that. All right. So those are the different compound periods that I may talk about today. When we calculate compound interest, there's basically two different versions we can do. Regular compound interest looks like this. I would never make you memorize this formula, so I will give it to you on any test or quiz, but I'm not going to tell you what all the variables stand for. So I want you to be familiar enough with it that you know that. A is your ending amount. A lot of times that's called future value, what you will have in the future. P is your principal, or sometimes called the present value. It's the amount we have right now. R is your interest rate. That always has to be in decimal form. So a rate is a percent. You have to put it in decimal to use your formula. N is the number of times we are compounding in a year. So that would be like monthly is 12, daily 365, so forth. And then T is the time, but that is always in years. So if I give you months, you have to convert that into years first. All right, so we have to be able to use that one. The second one, so we can compound over and over and over again. And the more you compound, the faster your amount grows. So this, we could do daily, but we could do more often than daily. I could compound hourly, or every minute, or every second. And as you continue to do that, it turns into what's called continuous compounding. So that's the second. A equals PE to the RT power. If you look at the calculator, there is an E button. If you do second and the natural log, the ln button, you'll get your E. So it's a set number, kind of like pi. A is still your future value, P is still your present value, R is still your interest rate, T is still your time in years. You just don't have an in here because it is continuous, and that's where the E comes into play. So I just want to practice some problems with this until we know how to calculate them. So let's look at this one. This is the first example I put on your handout, right? Okay. I have more slides than I printed for you, so I can always add more if we need to. Just want to make sure I'm doing the ones I printed. So find the amount in an account if $100 is invested at 4%, compounded quarterly, after a period of 13 quarters, and B, the amount of interest earned. So, to do these problems, I always start out kind of making a list. What would 100 be? Right, so my P is 100. What is 4%? And we always do that as a decimal, so 4% would be 0.04. When I say compounded quarterly, what does that tell me? So my N, the number of times a year, is 4. 13 quarters, what's that giving me? How would I change 13 quarters into years? So 13 divided by 4 is 3.25. Okay, so this one, the only time we use that E formula is if it says continuous in the problem. So there's no mention of continuous interest, so this is just our regular compound interest. So A equals P, 1 plus R over N to the NT power. So we plug in. P is 100, 1 plus 0.04 over 4 to the 4 times 3.25 power. So just plug this all in at once. Since we are talking about money, we will round to 2 decimal places. What do you get for your ending?
Wait, how many decimals?
2.
113.81.
So that's our answer to part A. How much we have in the account at the end. Part B wants to know how much interest we earned. How would we find our interest?
Do the amount that we got minus 100.
Yes. What you end with minus what you start with. So we found that we have $13.81 in interest. Is that okay? Let's look at this one. Leah must pay a lump sum of $15,000 in 8 years. What does the 15,000 represent? A. That's what we need to end with, not what we have right now. So A is 15,000. Okay, so part A. What amount deposited today at 4.8%, so my rate is 0.048, compounded annually, so my N is 1, will give us the 15,000, so that's my final amount, in 42 months. So what would my time be? How do I get
Be like 3.5, right?
You have to take your 42 divided by 12, 12 months in a year. And you get 3.5.
Would we only do 3 though, if it's compounded annually? So that's a fully completed year.
We'll still go ahead and include that 0.5. So assuming that then they would give them basically half the interest for that year. Okay, so we're trying to find the amount today. So we are actually looking for the present value on this one. So A equals P 1 plus Rn to the NT power. So A is 15,000 equals P 1 plus 0.048 divided by 1 to the 1 times 3.5 power. If you want to clean that up a bit, you can. But ultimately, what am I going to have to do to get P by itself?
You have to divide.
So what I would do to try to avoid rounding error, I'm just going to type in as 15,000 divided by the 1.048 to the 3.5 power. And we get $12,729.95. Part B says, let's say we only have 10,000 right now. What does the 10,000 represent?
The present.
We still need the 15,000, so my A is 15,000. All right, let's assume, okay, so it says what annual interest rate, so my N is still 1. We're trying to find the rate this time. I did not mention a time in here, so let's assume it's the same time as part A. So the 42 months or the 3.5 years. So A equals P 1 plus plus r over n to the nt. What could we do here? What should I do with my 10,000? Start there.
Extrapolate
It's multiplied.
the
We get 1.5 equals 1 plus r divided by 1 is r. 1 times 3.5 is 3.5. How do we get rid of that 3.5 power? Mm-hmm. If it was a square, you would add a square root, so here we're adding a radical. Okay, I try to avoid plugging this in the calculator until the very last moment so that I don't have multiple roundings in the same problem. So then what would you do to get r by itself?
subtract the r.
So we get 0.1228. Or if I asked you to give that to me as a percent, what would it be? Issues with these so far?
How did you plug in the 3.5?
If you do push 3.5 and then go math, number 5, it gives you that. Okay, I'm going to do one more with you and then have you guys try one on your own. So let's look at this one. This is the next example on your paper, right?
There was one before.
Oh, sorry, I did them kind of out of order this time. We're on that one. Okay, find what investing $1,000, an annual rate of 10%, compounded continuously, would yield. What is the 1,000? Is it what we want to end with or what we have right now? It's what we have right now. So that's our P. We want to find what it will yield, so we're looking for what we're going to end with. The rate is 10%, so R would be 0.1. As soon as I say compounded continuously, what are we doing? Mm-hmm. Well, not even every day. More specific, we're doing the continuous interest formula. E to the RT. Okay. Did I tell you the time? No. All I said was annual, so what could we use for RT then? 1 year. Okay. So P is 1,000. E to the 0.1 times 1 power. So 1,000, if you do second, the natural log, it'll put the E and then move you up to the exponent. We should get $1,105.15.
What did you do?
you guys try the next one on your own. Looking for the present value. That's what we don't have. So what's 100? After 2 years, so the time is 2. 6%, so rate is 0.06. Compounded monthly means my n is 12. So we're using our regular compound interest formula. A is 100 equals P 1 plus 0.06 over 12 to the 12 times 2 power. So you're welcome to kind of clean this up a bit. One plus 0.06 divided by 12 is 1.005 to the 24th. So to get P by itself, you have to divide. So 100 divided by that gives us its money, so 2 decimal places, 88.72. Is that okay? Last two. What annual rate of interest? So we are looking for the interest rate. Compounded annually, so N should be, should you seek if you want to double your investment in 5 years. So my time is 5. All right. Did I tell you the A and the P? No. All I know is we want to double it. What did you say?
The A sort of. A is just 2P, right?
Yes. So there's a couple ways of doing it. One option is to say, well, I don't know what I'm starting with, but if I want to double it, we would have to end with 2 times that. And some people are comfortable with that, and some people really are not. So the other option is just to make up a number. How much money do you want to start with? $100. If you want to double it, then how much do you end with? 200. So if you're more comfortable having those numbers, you can plug them in, and it's going to work out the same. So if we did that, and you divide by your 100, or if you did P and 2P, you divide by P, no matter what, you get 2 on this side. This is 1 plus R to the 5th power. So get rid of the 5th power, we do the 5th root. And then to get R by itself, we would subtract 1. So the 5th root of 2 minus 1. So we would need 14.87%. Last, find the amount in an account if $2,000 is invested at 8.5%, compounded continuously after 2.25 years. So when I say find the amount in an account, what am I looking for? So my P is R N sorry, I didn't mean to do N. I meant T. Because we didn't have an end, did we? Because it said continuously. So when I see that continuously, that tells me I'm using the PE to the RT formula. So my time is, so A equals 2,000 E 2.085 times 2.25 pounds. And we can just put all of that in the calculator. $2,421.52.
Did you move the decimal?
Oh, we did 200.
Two, I can't remember that. Okay, so
You're welcome. Okay, so this is the end of the section. You guys have that handout from yesterday. The book problems are here, mostly odds, so you can check yourself, but that also means you can't just write down a final answer. So write down what you're plugging in. So you've got the rest of class today, and then it'll be due on Monday.